Hey there, this is Math 7, Unit 3, Lesson 2. We're looking at exploring circles today. So really this is an introduction lesson to circles, just talking about what a circle is and just exploring circles. One of the key takeaways from today's lesson is really understanding that a circle is a set of points equally distant from the center enclosing a circular region. Okay, meaning that if I have a center, right, and I have a set of points that are all equally distant away from that center, they're going to enclose a region that we refer to as the circle. Okay, so that's my little circle. Here's my center. Here's my points that are equally distant, not perfect, I know, from the center. And that's what we're talking about today when we're talking about circles more than anything else. You began by exploring a couple figures here that said here are two figures, and it said that there was a figure C that looks more like figure A than figure B, and to sketch what figure C might look like. All right, and there's no really right or wrong answer here. You're just kind of looking at, well, I have one that's a little bit like A and less like B. Well, probably what we're going to talk about is something that might be maybe it's a little more curvy than A, but so it's a little bit like B, but it's maybe not as skinny. So maybe if you took like a square and you thought about rounding off the corners each time, and rounding off the corners and rounding off the corners and rounding off the corners, you get something that was similar to A with a little bit of B mixed into it, so you get a little bit of curve action there. But it wouldn't be necessarily a skinny, tall oval. It's still a little more squarish, just a little more curved on the sides. I don't know. This is just your thinking. What do you think could work there for your picture, to have a figure C that's more like A than B, but has a little bit of B in it? So maybe we're just curving off those edges here, curving off. Again, up to you. You get to explain and think about what do you think is different there. You then went into an activity with your classmates about sorting round objects, and you were given a variety of objects that you could sort into different groups. And so you had things like a utility cover, which looked a little bit more like a circle, a grill that was like a circle, a basketball, which was kind of, it's a circle in one sense, but it's also a more like a globe. Hard to say. It's that three-dimensional shape, so I don't know, maybe it's separate for now. A platter looks a little circle. An orange slice looks like a circle. Wagon wheel, pretty circle. A dartboard, circle. A boiled egg. Well, the inside part is a little more circle, but the whole thing is a little ovalish. Might put that over there for now. This rug, a little bit more like an oval. The speedometer. Well, the top part's definitely like a circle, but it does have a little chunk down there. I'm going to put that with a basketball, kind of like in the other category. I'm not quite sure where I'm going to put it for now. A fan cover, a little circular there. A propeller going around like that does create that circle. That center pivot irrigation, nice. We have the circle region there where it's growing. Clock, well, it's definitely more rounded, but yet it's also a little bit chopped off there. So we'll put that with the other category. And a pizza, I guess if it was a whole pizza, we might consider that it would be rounded there too. And then you had three others. You had a glow necklace, which we'll come back to in a second here. We had a bike wheel, and we had a yo-yo trick, each of which made a nice circle. And so you're looking at those shapes, and you organize them with your classmates based upon how you saw them. Circles, oval, maybe some oblong things, but you're really just having some conversations about the differences in all those shapes. Okay, but with all those shapes, there were some things that they tended to have in common, and that's really what we're talking about today. All circles, in terms of being a circle, they're going to be round, right? They're going to be an enclosed plane figure. Okay, so they're going to be round, it's going to be enclosed. Circles tend to not have any edges, right? So no edges, so that clock one wasn't really going to work for us too well. Okay, we could say they have no vertices, right? No sharp corners, that kind of thing there. Your diagonals are equal. meaning if I cut across any one of these points here, I'm going to find that I end up being in the same place. So let's take, for example, our fan, right? In terms of diagonal, the lines across are going to be the same length. No matter where I go, that line across the middle, I'm going to get the same length straight across. So those are some different things you might have seen. The distance around a circle is always, maybe you knew this already, 360 degrees. Maybe that's there. There's a center point for all these here, and it's the same distance from the center to the outside edges. Again, things you might have noticed or talked about in your class today. It then asks you to put them in order from smallest to largest, meaning based upon what they would be in the real world. And then it says to select one of the pictures of a circular object. What are some ways you can measure the actual size of your circle? Okay, so if you're going to find the actual size of a circle, how would you go about doing that? Let's take, for example, if I had the dartboard, how would I figure out the actual size of a real dartboard there? Okay, and so maybe I could look at maybe a line across, and I can measure a line across the diagonal across it, so I could look at my longest line across the object and use that perhaps to measure what it might be. I might want to, maybe I could find a way to measure around the edges. Okay, a way to look around and say, well, let's measure around there to figure out how large that might be there. I could also look at the center and go from the center to the edges to figure out how long something could be, whether it's from here to there, here to there. Maybe I could work that out. Again, we're just exploring it and talking about it. Okay, so that's just an idea there. All right, on January 3rd, the Earth is, this is a ready for more question, which sometimes we do, sometimes we skip. That's kind of a nice one here because we live on the Earth. The Earth is 147,500,000 kilometers away from the Sun. So over here, we're 147, I'm going to just put 147.5 for now. Okay, on July 4th, the Earth is 152.5 kilometers away from the Sun. And it says the Sun has a radius of about 0.865. I'm putting my point there because that's where I started making decimals before. Question is, could the Earth's orbit be a circle with some point on the Sun as its center? And we'd have to figure that out, okay? If this was a perfect circle, and that's the center, then we would expect that these measurements should be about the same, or that there could be a point somewhere inside of there that would get me where I need to be. The problem with that is that if I was to add the distance of the Sun, or the width of the Sun, to either one of these, even adding it over to here, I would have 147.5 plus a 0.8 something or other, and that gives me 148.3. I still have too much of a difference between this length here, or this distance here, and that one there. It's too long. This is longer, and this one's a little bit shorter. And because it's long and that's short, I don't have a perfect circle. And there's not a perfect point in the center that'd be a perfect center point for this and the Sun, at least, for that to go around. Could it be going in a circle? It certainly could be, but that center point won't be in the Sun. It'd be somewhere over here to make an actual center point. Again, this is a drawing, so it's not accurate, but it gets you an idea. Let's look at the next activity, activity number 3 on measuring circles. Okay. Priyahan and May each measured one of the circular objects from earlier. One measured the bike wheel at 24 inches, one measured the yo-yo trick, and one did the glow necklace. We have these pictures here. Okay, so this guy says 24 inches bike wheel, yo-yo trick 24 inches, and the glow necklace 24 inches. Do you think that all these circles are the same size? Well, I mean, just in terms of reality, 24 inches, I could see a bike wheel perhaps being 24 inches across, perhaps. This yo-yo trick there, I mean, the girl is probably taller than 24 inches, and we can see the yo-yo trick seems to be as tall as the girl, maybe like, 5 feet. So I'm not sure where that 24 came from. And a necklace usually is a lot smaller than a bike wheel. So the 24 inches must be saying something different about each of these pictures there. Not really sure what they're talking about there. Okay, so do I think they're all talking about the circle being the same size? we would say, nope, not the same size. They're not all the same size. These are different objects here that we're talking about. So what part of the circle do they measure? Because they do have a measurement, so what were they talking about? All right, so in terms of the bike wheel, that 24-inch thing, for the wheel, 24 inches is probably going to be best to be what we might call the diameter. Okay, and that diameter is going to be the distance across from one edge of the tire to the other edge. That's probably a good guess on the bike wheel there. Okay, 24 inches across. And when you buy a bicycle, you know, you'll buy them and they have the tire size. There's always a number on the bike wheel that says how big the tire is. Or if you want to get a new tube that goes inside there, it'll be something like a 24-inch tube. Take a look next time you're shopping for a bike tube or bicycle. When you look at the yo-yo trick, that 24 inches there, well, that 24 inches for her, this is definitely, 24 inches is the same as 2 feet, right? Okay, and we said the girl's probably about, 5 feet tall. So we think of it this way, if that's my center, I could probably go out there 24 inches and out here another 24 and 24 and 24. Her 24 inches is probably best to think of that as probably going to be the radius. And that radius is going to be the distance from the center to the outer edge of that circle. That's what she called 24 inches there, or Han says 24 inches there. In terms of the necklace though, the necklace is a whole different thing, because now 24 inches makes more sense in terms of what we call the circumference. And the circumference is the distance around the object there. And that's going to be how they got 24 inches there. So the 24 inches all represent different things, whether it be the diameter, or a radius, or perhaps a circumference, the distance around the object there. These are all three different tools we use to describe and measure the sizes of circles. Okay? So the next activity had you taking a ruler, and it said, let's go ahead and we're going to make circle A with a diameter of 6 centimeters. So diameter, remember, was the distance across the circle. So if I take a point here, I'm going to go 0 out to 6. I know I need to be about that wide right there, 6. And the first thing I do when I do this, if you had a compass, it'd be easier to do, that's for sure. I didn't bring my compass home with me, so I'm going to put a point at the midpoint. Here's 3 is halfway through, and then I can just use my ruler and turn it sideways, make a little 90-degree angle there, and draw another line from here down to 6. If I want to draw a couple more, I could, just for fun. All right, pop that right there and go across. Whatever helps you kind of have more dots to connect. So I put a line there, put a line here, and then from there, if I wanted to, I could just kind of slightly sketch out what that circle might look like. And there's my circle with a diameter of 6 centimeters. Okay? All right, there's my circle with a diameter of 6 centimeters. So the diameter is 6 centimeters there. That's my whole length, 6, which means my radius is actually going to be 3. That's my radius, but the whole thing is going to be 6. Okay, turn the page to our next one. Set to make another circle on the next page with a radius of 5. All right, so radius of 5, that's going to be the distance from the inner part of the circle, the center, to the outer edge, 5. Okay, so that's my middle of my circle there. And I could just draw a few of these. Again, it doesn't really matter how many you draw, it's up to you. We're going to sketch them out to 5. So we go from 0 out to 5. And again, the more accurate you are with this, the nicer your circle is going to look. I'm just making a quick sketch because this is just review from class anyways. So 0 out to 5. And then you can play connect the dots like this and have a nice circle with a radius of 5 centimeters, something like that. Okay? For number 3, it says circle C with a radius that is equal to circle A's diameter. Okay, so circle A's diameter was 6, so now we're going to make that the radius. So now we're going to make a longer one here. We're going to come out to about here, and we're going to put a point. We'll put a point right here for our middle of our circle, and we'll go out to 6. Okay, and knowing that that's 6, I could then go straight across and say, well, let's make my other one going out to 12. We'll go up this way to 6. We can come this way. We're at a lot larger circle, that's for sure. 6 to 12, and 6 to 12, something like this. Okay, and again, we'll connect those dots together and have a circle something like that, where now my radius is 6 centimeters and my entire diameter would end up being 12. Okay, for something like that. And we'll do one more of these here before we get onto the homework and the summary. It says circle D with a diameter that is equal to circle B's radius. Well, circle B, recall, had a radius of 5 centimeters. Okay, so 5 centimeters with a radius. Well, we're going to make that 5 centimeter radius, we're going to make that our diameter now. So our diameter is going to be 5 centimeters. So the whole distance across the circle from 0 to 5 will look like that. That'll be my width of my circle. Okay, so now I want to find the midpoint of that, which is about 2.5. Because 2.5 is half of 5. And then I can jot that there. I can make another line here to here. And then again, knowing that that is going to be about 2.5 centimeters, I connect those dots up. And we have our circle at about that size. Okay, if I've asked you to use a compass tool, which I didn't bring with me, to recreate those, and you could do that by making those same links and drawing these same shapes there. All right, let's look at our summary for today. It says, first of all, that a circle consists of all the points that are the same distance away from a particular point called the center of the circle. So it's all the points that are the same distance away. So here's the circle, and here's the center, and the circle is all the points that are the same distance away from the center of that circle. That's what's going to make our circle. Okay? The segment that connects the center with any point on the circle is called a radius. Okay? So the center to any point is called the radius. So a point that's a radius could be like from P to F. This segment right there could be considered a radius. Right? Okay. Now the other thing we looked at though is we have the segment that connects two opposite points on a circle passing through the circle center is called a diameter. So if it goes through the center and connects 2 points straight across, so C and D, but through the center, we could call that the diameter. Those are ways we would look at that there. The other thing we talked about here a little bit was also the circumference. And the circumference of a circle is the distance around it. How far around the circle is a measurement, okay? So if we took a string and we were to cut it, cut a piece of string and go around it for something like this, we could go around an object and figure out how long it might be to go around that object. And then once we were done going around it, we could take that string and make it straight and get a straight line and go, oh, it's going to be such and such length, okay? That's what we're looking at today. So radius, diameter, and circumference were your keywords there. So press pause and then get started on your homework and then come back here to see how you did. All right? I'll turn my page. All right. For number 1, it wants you to use a geometric tool to draw a circle, draw and measure a radius and a diameter of the circle. Again, best to probably do this with a compass, which I don't have with me, but with a compass what you would have is you'd have a pencil, you'd have a point like this, like almost like a V, right? And you would end up taking it and you'd trace it around that shape like this and get a nice curvy line. Point is you have something standing steady and you have a circle that's going to be created around that. All right. From there, you could then draw and measure a radius, where you take a dot and go across and measure a length there to be your radius. Again, yours would be different than mine. And then a different dot from opposite sides through the center, you can measure a diameter there. So you'll have some shape that looks something like this on your paper. You need to measure that and find the actual distance from the center to the edge and from edge to the center for your radius and your diameter. Okay? All right, number 2. Here is a circle with H as the center and some line segments and curves joining points on the circle. Identify the following and explain your reasoning. Diameter. Okay. The diameter is going to be from edge to edge and through the center. That's what a diameter has to have. So when we look at a center point here, I need to find a line that goes edge to edge and through the center. And I do have a couple choices. I have E to A, that works great. And I also have D to G, that works great too. It needs to be a straight line. If you were to look at this one here, B to F, while that does go from edge to edge into the center, it's not a straight line. It needs to be a direct straight line through there. So I could say EA, or I could say DG. Those would both be just fine, or you could call it AE and GD. That's okay too. For the radius recall is going to be from the midpoint to an outer edge. Okay, just that distance right there. So when I look at the midpoint here, I want a straight line from there. I have a straight line going from H to E, H to D, H to A, and H to G. All those are just fine. I could write HE or HD or HA or HG. Any of those are going to work, and any of those would be acceptable answers for your teacher, I'm sure. Okay, let's look at the next page, number 3. It says Lynn measured the diameter of her circle in 2 different directions. Measuring vertically, she got 3.5 centimeters. Measuring horizontally, she got 3.6 centimeters. Explain some possible reasons why these measurements differ. So here's the idea. She has a circle, all right? This is, again, it's a sketch. And she did diameter, and she went vertically, and this length was 3.5. And she's thinking, okay, I got the diameter, got it. And then she went over here and went that way and went 3.6. And she's thinking, well, something's maybe not right. Why? Well, maybe there was an error in just her measuring. Maybe just she measured it wrong a little bit, right? Is there a huge difference between 0.5 and 0.6? It's about that much, right? There's not a huge difference between 0.5 and 0.6. It's a small little space there. So maybe she mismeasured just a little bit there. Maybe, okay, it's not a perfect circle. Maybe the circle was just not done right. I've drawn circles all through this whole lesson that aren't perfect. If you measured them, they would not be right. They might look good at first, but once you measured it, not very good there, okay? And maybe there was something that, when she went through, what happens if you take your line and if you measure a little bit off? If I measure from here to here, I'm going to get a smaller length. Notice how the further I go from the middle, I get a smaller length. And perhaps she wasn't measuring straight to the middle. If you don't measure straight to the center, you're going to be off there. So lots of reasons why it could be off, yet still could be a circle. All right, number 4. Number 4 is a review from Unit 2. So let's take a look here. It says a small test batch of lemonade used a 1/4 cup of sugar added to 1 cup of water and a 1/4 cup of lemon juice. After confirming it tasted good, a larger batch is going to be made with the same ratios using 10 cups of water. All right, 10 cups of water. So we had sugar, we had water, and we had lemon, right? And with our initial one, making a table here, we had a 1/4 cup of sugar to 1 cup of water to a 1/4 cup of lemon juice. Would you all agree to that? Okay, so a 1/4. Zoom in a little bit, just a little bit small. Yep, so a 1/4 and 1 and a 1/4. Now we're gonna make it with 10 cups of water. And we want to know how much sugar should be added so the batch tastes the same, okay? And we can look at it this way. To move from vertically from 1 to 10, I'm multiplying by 10 there in that relationship. So if I multiply this by 10, I'm increasing by 10 times, I get 10 over 4, which can be reduced down to, or rewritten as 2 and 2.5, sorry, 2.5. Same over here, 10 over 4, which is written as 2.5. So in terms of what I would do For how much sugar should be added to each one, I would go with 2.5 cups of sugar if I'm going to do it with a 10 cups of water there. So you just want to see what's the relationship, 1 to 10 and 1/4. I'm going to multiply also by 10, and I get 2.5 cups of sugar there. All right, and number 5. It says the graph of a proportional relationship contains the point with coordinates 3, 12. So it's like here 1, 2, 3, and up here at 12, way up here. So I have this 3, 12. There's my graph, 3, 12. What is the constant proportionality of the relationship? Our k value, if you recall, is always our y over our x. In this case here, our y value is 12, and our x value is 3, and 12 over 3 becomes 4 over 1, so our constant is going to be equal to 4. And that's our constant proportionality. That's a review from Unit 2. All right, hope that helps you out with your homework and your lesson today. And good luck, and we'll see you next time.